Okay, so good morning, happy Monday, happy February. We're jumping in on page 17 today. First, our quick look at the calendar. Today, February 1st, we're talking about lesson number 3, which is linear models. There are going to be more word problems today. And I just want to point out that although no homework has been due officially yet on Mymathlab, that's going to end starting on Wednesday. All 3 assignments, first 2 classes and today's assignment, will all be due this coming Wednesday. And then from that point forward, homework will be due the very next class, almost always. Okay? Any questions on the homework? Okay. So here on page 17, just a couple of quick announcements before we jump in. So first of all, I have given you one more handout. This will be the last handout for a long time. Go ahead and grab one of these Mymathlab tips and tricks. Last class, I gave you a handout about just some of the basics of using Mymathlab. Now you are going to become professionals at using Mymathlab. You're going to save yourself a lot of time by learning just a few very useful shortcuts. Doing things on a keyboard is typically faster than a mouse. This will give you ways to do some things on the keyboard instead of the mouse. All right, so I recommend reading that. Next, many of you have answered the questions that I asked you about the syllabus, and one of the questions I asked you was, what questions do you have for me about the syllabus? And I want to respond to the questions that I've gotten. Is it okay to leave my hard copy of the book at home, or would you like me to bring it to each class? Great question. We're never going to be using the actual textbook in class, so feel free to leave that home. Save your spine. Will you always be available in the math studio from 8 to 8:40? I will not be available in the math studio 8 to 8:40, but if you look at the bookmark schedule, you'll see that Caitlin is always there 8 to 8:30. So that's a great resource. The time that I come into GCC varies from day to day. I'm typically here by 8:15, and as soon as I'm here, I'm almost certainly available to answer a quick question, but I don't have a lot of time. I usually come here like 8:25, 8:30 just to start getting set up for class. So you can come find me in my office if you wish, but safer would be Caitlin in the studio before class. Is there any point that the lessons will not be posted on YouTube? My plan is to record every lesson and post it on YouTube. Occasionally, I forget to do a step and don't record the audio. I'll still post the video, but having a silent video of our YouTube classes is not all that great. So I'll do everything I can to post these videos every class. Thank you for the questions. Okay, on the top of 17, starting lesson number 3 with the daily summary. In this lesson, we solve word problems that involve linear equations, and we graph lines using intercepts. We also learn how to identify dependent and independent variables, as well as how to write an equation for one variable in terms of another. Okay, I've made this announcement number 0 before, but I'll say it again. If you answer a homework problem on Mymathlab and you think you have it right, but Mymathlab says it's wrong, send me an email. Also, if you haven't signed up for Mymathlab yet, you can sign up for a free trial. Do that ASAP. Again, it's easy for me to tell whether or not you got the thing right, so don't spend an hour working on the same problem. That is not a good use of your time. Just send me an email. Number 1 reminder, our default is that you are not using your calculator unless the instructions tell you to do so. A model is a mathematical description of a real-world situation. Suppose an individual works X hours at a salary of $15 per hour. Part A says fill in the table of values showing the wages W in dollars earned for the number of hours worked X. Let's fill this table in together. X, again, is the number of hours worked. If you work 0 hours, what will your wages be? 0. Sad but true. If you work 4 hours, again, you are earning $15 per hour. What are your wages? Is 60. How did we get 60? Yeah, so 15 times 4 gives us a 60. Easy. Okay, next one. If you work 6 hours, what's the calculation, not just the final answer? Yeah, 15 times 6, which is 90. And then finally, if you work 10 hours, $15 an hour, 15 times 10 is 150. Now this gives us a bunch of points. I'll just write one of them out here. But X is 4, and when X is 4, the wages turned out to be 60, so you can think of that as the point 4 comma 60, which you can plot, and which I want you to plot right now. Go ahead and plot all 4 of these points on this graph paper right here, and then we'll come back together. Okay, and if we plot those 4 points, what do we notice about all 4 points? They're all on a straight line. Go ahead and draw that straight line. Grab the folder or some other straight edge to help you. And this line represents the wages that you get for working X number of hours. Part C says write an equation for W in terms of X. Now this is the first time we are using the phrase in terms of in our class, and it has a very precise mathematical definition. Here it is. This means write an equation of the form W equals some stuff with X's in it. That's my informal way of writing that. W equals some stuff with X's in it. W in terms of means W equals. So as soon as I see the phrase in terms of, I write an equal sign. W in terms of, W equals, and then there's going to be some stuff with X's in it. So in this case, some of you might be able to very easily see what W is equal to, but even if you can't, take a look at the pattern we wrote out in the blue table here. 15 times 4, 15 times 6, 15 times 10, 15 times, in general, X. Right, that's the calculation. So 15 times X. There is a formula for W in terms of X. For each increase of 1 hour, how much more does the individual earn? $15. Does this hourly rate change or stay constant? Constant. There are some places where it doesn't stay constant, right? When might your salary change working the same job? If you work overtime, or maybe a holiday, right? That's not described in this example. This is just a flat $15 per hour, and that is the rate at which you're earning. And for each additional hour worked, there's always an increase of $15. This is an example of a constant rate of change. It's $15 per hour, no matter what. This constant rate of change between two variables, the hours worked and the wages earned, is what distinguishes linear models from other types of models. We're going to talk about these kinds of graphs later on in the semester, but just a quick detour here. This is the graph of the equation y equals x squared. It says, notice that the rate of change is not constant in this graph. Let's take a quick look at our graph up here for a second. Every time, let's see, I go over 1 hour, how much more money do I earn? $15. And you go over 1 hour and you earn $15 more. And every time you go over 1 more hour, you go up 15. And in fact, you guys have probably seen the word slope before and maybe a picture that looks quite similar to this one. But if you look at this curvy thing here at the bottom, if I go over 1, turns out I go up 1 there, but the next time I go over 1 to get to the graph, I actually have to go up 3. And the next time I go over 1, I actually have to go up 5. And do we see that it is not the same triangle every time? And that is not a constant rate of change. But everything linear is a constant rate of change. On the next page, more vocabulary for us. We've defined in terms of. Now we're going to define dependent and independent variables. Since our wages depend on the number of hours we work, we call W, wages, the dependent variable, and X, which was the hours, the independent variable. Right? The wages depend on the number of hours you work, dependent variable and independent variable. So if it helps you to remember, let's go back to our equation. We wrote this equation on the previous page. W equals 15x, right? And what I'm saying is that W is called the dependent variable and X is the independent variable. So here's a little silly mnemonic device. Maybe it will help you decide which one is which, but looking at that equation, as soon as you see that equation, I want you to get to a place where you can say, oh, W is the dependent and X is the independent, even if I didn't tell you they stood for wages and hours. It's just by looking at that equation. So if it helps you remember which variable is dependent and which is independent, think of Johnny Depp on an island by himself in Pirates of the Caribbean. Thus, the dependent variable is the one by itself in the equation. By it, the one letter that's by itself in the equation is like Johnny Depp on an island by himself in one of those movies. And so the one that's by itself, the letter that's by itself, is always the dependent variable. Yes? Taking a look at these two equations here, r equals t over 121 and t equals 121r, which both represent exactly the same thing. Write down the one that expresses t in terms of r. Which one of those is the one that represents t in terms of r? Just copy that equation over here. Is it the first one or second one? Second one. T in terms of means t equals. So far so good. That's what we defined on the last page. And now we're going to figure out which one of these is the dependent variable. Which letter is by itself on the island? T. Which letter is the dependent variable? Dependent is the t, the one that's by itself. So since t is by itself on the island in the equation we just wrote, t is the dependent variable. And then by process of elimination, the other one must be the independent variable. So r is the independent variable. And it works that way every time you have an equation, whichever letter is by itself, we call the dependent variable. Any questions on the vocabulary? Okay, last new thing for today that we'll do together here is number 3. It says we're going to fill in the table with the intercepts of the equation 3x plus 2y equals 12, and then we're going to graph the line 3x plus 2y equals 12. Now I know many of you have experienced graphing lines before this class, and some of you feel obligated to solve that equation for what letter? I know some of you want to solve that for y. You are desperate to solve that equation for y, right? Y equals mx plus b was handed down from the heavens. Any equation with x and y, got to solve for y. All right, it is true you could solve this equation for y and graph the line and end up with the same graph that we're going to come up with over here, but I think that is not the easiest way to graph the line. I'm going to show you what I think is the easiest way to graph the line. So take a look at this blank table here. Notice that I've picked x is 0 and y is 0. I pick 0 and 0 because those are the easiest numbers to plug in. So we're just going to take a look at this equation right here, 3x plus 2y equals 12. And one at a time, we're going to plug in x equals 0 and y equals 0. So for example, if you plug in x equals 0, the equation becomes 3 times 0 plus 2 times y equals 12. Yeah? All we did was plug in x equals 0. Y 0, because it's easy to plug in. You could equally well plug in x equals 174. But 3 times 174 is not as easy as 3 times 0. It's the only reason we pick 0. Pick anything you want, but I pick something easy. 3 times 0 is 0, so that term doesn't contribute anything, so I'm just going to copy what's left. 2y equals 12. Yeah? And then divide both sides by 2 to get y equals 6. And I put that right there in the y column. When x is 0, y is 6. And then we'll play the same game, but now we're in the bottom row. We're going to let y equal 0. Again, going back to the original equation, 3x plus what? 2 times 0 equals 12. And then we'll do just a little bit of work to solve for x. So this becomes 3x, 2 times 0 is 0. Not even going to bother writing it. It's just 3x equals 12. Divide by 3, we get x equals 4. Any questions on that? Go ahead and put the 4 in the table. Okay, a really common mistake. I want you to avoid it. We found that x is 4 and y is 6, and it is very, very tempting to write down the point 4, 6. After all, x was 4 and y was 6. But that is not okay, because the 4 and the 6 came from two completely independent thoughts, and they have nothing to do with each other. But as soon as you put them together, you're saying, hey, these two guys are related, and they aren't. The 6 only came about because we chose x equals what number? 0. The 6 is only here because of the 0. The 6 has nothing to do with the 4. The 4 only came in when we let y equal 0, and they're separate points. It's not that. So this is the point 0, 6. This is the point 4, 0. Do not compress them to the point 4, comma 6. So we've got 2 points. We're going to plot them on our graph paper. 0, 6 is up here. 4, 0 is over here. And 2 points determine a line. So go ahead and grab your straight edge, your folder, your bookmark, and connect the dots. And I think that's the easiest way to graph a line when the x's and y's are on the same side of the equation. Just some quick vocabulary here. What is the name of this point right here? X-intercept. Yeah, the point that's on the graph of the diagonal line, that's on the x-axis is called the x-intercept. And likewise, the point on the y-axis is called the y-intercept. And not surprisingly, this method that we just used to graph that line is called the intercept method of graphing a line. Questions on that? Okay, so do not feel obligated to solve equations for y, not today anyway. We can just find the 2 intercepts. All right, activity starts after the answer key to the demo. I will walk around and help if I can.